This is How to Smash Your IA, the Pandemic Edition. Let's start with the advice from the International Baccalaureate Organisation. Biology, chemistry, physics, we should be using a spreadsheet, a database, a hybrid of the two, a simulation, or some phone apps. Let me make it clear right now, I don't suggest anybody go out there and do home-based experiments unless they are very, very limited, very narrow in their scope, because of some major health and safety concerns, which certainly would make me lose sleep at night. There are many ways to begin an IA, whether it be primary or secondary data. Here are some examples of other teachers, these are not mine, suggestions for research questions. Just the same as your standard experimental based IA, everything stems from a fantastic research question. This is the latest advice for schools for 2020. If you started, that's what you need to do. If you've not started, that's what you need to do. I expect that some students may be watching this with a view to the November 2020 session. I hope that you find some of this of some assistance in your quest to succeed. I'm also a moderator. This is what the IB tell me to do. Be open-minded and reward independent thinkers and risk takers. This is a golden opportunity. I think this is a boon. This is fantastic. We can actually embrace some stuff that we've been dying to do for a long time. This was freely available on the IB Chemistry Facebook teachers page, and it will guide you through. I'll put a link to the document underneath the YouTube video and give some guidelines about what you should be doing and how you should do it. I don't purport to be anywhere near as expert as the people that made this, and I'm very indebted, and thank you very much indeed for allowing me to share this on the YouTube channel. Okay, so there's some great websites here for modeling and for simulations and for databases, and there's some examples, and there's the people that we should be very grateful to. It's freely available, so I hope it was okay to share it during the making of this video. ACS, the American Chemical Society. Here are well over a dozen different virtual chemical experiments that you can do. If you look further, here are 64 free chemistry databases for you to interrogate. When you're doing this, please make sure these are for real chemicals, so they've got element symbols and formulae, not of the type ABXY equals A2B. We want to be real chemicals. This document is also freely available on the Chemistry Facebook teachers page, and again, there are dozens and dozens of different sites that you can use to help you. So, welcome to how to get 24 out of 24 in the age of COVID internal assessments. This is general guidance, and one of the main problems we have is where on earth do we start? We've shut the laboratory, there are no burettes, there are no pipettes. Students are frantically checking Amazon for chemicals. Please don't stop doing that right now. So this is how to do it safely and how to get a good result in your internal assessment. I can't emphasize enough that the criteria are exactly the same. The criteria have not changed from the experimental primary data form of internal assessment to secondary data. So what must we do? Well, the guidance is pretty similar, though I have adapted it since the previous video. Have a research question which looks like it will take 10 hours. That's great. Why is that great? That's great because for secondary data, you can look at the relationship between electronegativity and chemical shift in an NMR spectrum, perhaps. You could look at position of a methyl group and on a benzene ring and where it will shift down the spectrum. That will take you about, 30 minutes? And people marking your IA know that took you about 30 minutes. The IA should take 10 hours. So be free to go beyond the 5x3 5IV in triplicate model, which we've been using for experimentation successfully for many years. So your research question is not restricted by the effect of X on Y. You can look at many different independent variables. You can look at many different research questions or a multifaceted research question. The thing that people are going to fall down on is being restricted by the old model, using that for database. First point. Ensure your research question is open-ended and occupy the full 10 hours. We've done that. You can have any number of IV, DV, because don't forget your control variables will be almost next to impossible to discern. You're going to be looking in databases. you're going to be looking at simulations. The number that you are given is the number that you are given. Ideally, and this is the way to get 24, you need to find a database or a simulation which allows you to control the variables around the experiment which you are doing. There are some listed at the end of this document for you to explore and for you to investigate. But if your simulation is restricted purely to the independence and the dependence variable with no way of you controlling the variables around that experiment, you're going to be struggling to get the high bands within exploration and analysis on the internal assessment. So you need to choose your simulation very, very smartly. You should still aim for a graph where there is a calculation. Raw data is not enough. Well, you can plot raw data, but you're probably going to end up with somewhere between a 10 and a 14 out of 24 if you are just plotting raw data. Even if you just average the data and you average it correctly over 3 or 4 or 5, yes, you do have time to do that, different databases, then you are able to get the higher bands. Where do the errors come from? Well, the errors come between the different sources that you have used. You might use different universities for, I don't know, the electronegativity. You might use different universities for bond length or bond energy or whatever it happens to be that you're looking at. There will be a range in between the different sources that you have used. That range is the basis of your uncertainty. The rubric for marking IAs does not say that you have taken into consideration uncertainties correctly and propagated them appropriately. What it does say is that you have considered uncertainties. Considered, and that's the key word. You don't know the uncertainty on the data in the database that you are using. If they say it, brilliant, use it. But in many cases, they won't say that it's plus or minus 0.02 nanometers, whatever the data is that you're looking at. So you're going to have a look at University of, I don't know, Oxford, University of Cambridge. There might be a plus or minus 2 different on a kilojoule per mole reading, and that will be your uncertainty, the difference between those two sources. Obviously, you're going to be using more than 2 sources, but we'll get there. If you are lucky enough, the precision is given in the database. If it's there, use it, reference it. Happy days. Do not be restricted to one site or source. Okay, it's not a simple matter finding a simulation on, I don't know, the iodine clock reaction, doing the iodine clock reaction, writing up the times, getting the order of the reaction, and plotting a graph, maybe doing an Arrhenius plot. That's not what we are after. You could do that, but all you're doing is copying down. And did that take 10 hours? No, didn't take 10 hours. It took about 1 hour. Don't forget your moderators are chemists. They know what you're doing. Still, do not replicate known relationships. You could do enthalpy of combustion of alcohols. It will be even quicker online than it is in the laboratory. Still not going to score very well at all unless you are comparing many different sources. Perhaps you could look at different sources of those enthalpies of combustion. You could compare that using average bond enthalpy calculations. That's all database, that's all research, and that would perhaps make a pretty damn good IA. Known relationships, Q equals IT, it does, we know that. F equals MA, C is N over V, the list is endless. This is not a literature search. Okay, the IA and the EE are different beasties. You could look at lots of different labels and look at the amount of iron in the tablets, or you could look at the vitamin C on different company websites in different things. That's not what we're after. That's the beginnings of not a very good extended essay. That's not an internal assessment. We still don't care, or the IB don't care, whether it's standard or higher level. So don't you care about what the chemistry is that's in there, as long as the chemistry is correct and it is chemistry. Okay, it's very easy with these. It seems like physics are really good at these online simulations and databases. I've not looked at biology, but physics is great. Chemistry is so-so. There's some good stuff, and you need to be quite discerning on what you choose, because there's also some so-so and not very good stuff. Do not be restricted by the effect of X on Y model. It was great when we had a laboratory and burettes and pipettes and colorimeters. We might have a colorimeter, but we'll come to that. But you know, we are pretty limited with secondary data. So you can expand that research question. You can look at many different factors which influence the results. I'd say as a rule of thumb, this is not from anywhere, this is just from me moderating, looking at IAs. When I look at on the back page and I look at the references, I'm looking at personal engagement and exploration. I'm looking at the references. The references should still be good references. It shouldn't be, Wikipedia. Don't look what Wikipedia used to create that entry. Go to those references and use those as your references. Universities right now are kicking out so much material, and it's all free. It's all openware. You can just go on. You can use it. What a fantastic opportunity to have a look for those students that either want to get a perfect score on this, which hopefully you all do, or are going looking at university courses and getting a head start. And what a great way to show that you are personally engaged and you are exploring. And the hints for your analysis will be fantastic. If you look at first year university stuff, many of you will look and go, I can kind of understand that. What a brilliant thing to put in your IA. Personal engagement, again, it's worth saying, still see this from time to time, say since I was a little child, I've always wanted to know how the bond strength relates to the bond energy and the bond length. No, you didn't. Don't have a section titled personal engagement because it normally contains this sort of nonsense, which you don't get any marks for that. But please do set the scientific context. Make sure your equations are correct and are balanced and your calculations have units and any uncertainties are propagated correctly. Greater than 10, again, this is a Mr. Midgley reference. This is not backed up by any other person. It's just my own personal thing. Interpret your data correctly. It should feel like 10 hours of research. No moderator has a balance in their room, well I don't, on which we put the internal assessment and go, oh, that's 7 hours. No, but it should feel, we know what it looks like. We know what it looks like for 10 hours. And you should be genuinely curious. Your research question should be something you actually cared about. Maybe you've wondered about delta G and Kc and what's the relationship between the two, and you can plot some graphs about that, and that would be a great thing to do. Exploration. Don't expect a good mark if you're checking a label claim or just confirming the textbook or a known fact. And don't just rely on the textbook to get you a good score. The same holds for primary and secondary data. You should be doing extensive research around your research question. There's certainly no shortage of information. Do have lots of chemistry. If yours is kind of a slightly obscure take, I don't know, like soil pH or things like that, don't start going on about worms and loam and, I don't know, perforation rates and all these things. We want to see chemistry in a chemistry IA. There probably won't be, that I can imagine, I could be wrong, any safety, ethical or environmental issues with a database IA. Maybe I'm not thinking enough, but I can't think of any. Even if it's a nuclear reaction, whether any ethical issues with creating that data, maybe there. If there aren't any, say there are no safety, ethical or environmental considerations with this IA. Again, it's for the consideration of the safety, ethical, environmental, not for the completion of the safety, ethical, environmental. Explain how, if, and this will be in most cases, control variables are absent. They're absent because you're using secondary data. If you can find out what they are, very simply, no one expects you to be looking at the references at the back of the database and ringing up various universities and research institutes and saying, excuse me, how did you control the experiment when you did this data? That's not expected, but you need to show that you considered whether they existed. Analysis, you can get pages and pages of data with secondary, the same as you can with primary data. Put it in the appendix. Just put an exemplar within the body of your IA, which will explain what you're trying to convey as part of the exploration of your research question. What if it doesn't work? Well, welcome to chemistry. It often doesn't work. If you look at the data and you explain why it doesn't work, and you can propagate some uncertainties from that and talk about the absence of a trend, then you have correctly processed your data. That doesn't mean you're going to get any detrimental penalty to your score just because there is not a trend. There is no penalty for not finding a trend. Do process correctly. It'll probably just be averaging. I'm sure the IB know this. What else can we do? We're stuck here with no laboratory and a load of books. and the internet. So just make sure your averaging is done correctly. That will be checked. Sig figs will differ between different databases. You can leave them as they are and explain why you kept them as they are. Or you could go to the lowest number of significant figures, which I suggest is perhaps the best route, and then you are consistent throughout. Same with decimal places. Your graph, you're gonna have a graph at least. I'd suggest a number of graphs. Like I said at the beginning, the research question can have any number of IV and DV, so you can have any number of graphs coming out of this. So it's going to be quite a in-depth investigation. And any uncertainties, again, between websites, or if the precision is stated within the data, please use that. Discuss your trends, talk about whether there was a positive or negative correlation, or no correlation, a complete absence of a correlation. And then we get on to evaluation. And evaluation tends to be on all IAs where students run out of steam. They've probably been up all night. Evaluation starts at 4 in the morning. The submission is 9 o'clock in the morning. They're like, oh, what do I do? Or maybe you're more motivated than I was when I was a student. Okay, don't forget to reference your research question. If you were investigating the effects of substituents on arenes, IR spectra, don't forget to say whether they did have an effect on the positions in the IR spectra of whatever functional group you were looking at. Don't just say that your technique wasn't good. Does this hold true for this? I'm not so sure. That was from the primary data. The secondary data, your technique is looking up and pressing buttons. Probably not. You could say that you're going to use more precise equipment. They could probably state which machine or technology they were using to generate the data that you're going to be using in your IA. Perhaps you can find a better one. Or again, you can say, after extensive research, I was unable to find a better technique to gather this data. Maybe it was the best we have available at this current time. Do compare with the literature value. They're all literature values, aren't they? If you're looking at something, relationships between delta G and Kc, or let me think, you're using it to relationship between E0 and delta G, that would be nice. There should be some literature value. Again, state if you've looked for it and didn't find it. Highlight strengths as well as weaknesses and quantify them in the limitations of the data. If there was a big drift between different databases, have a guess why. Why was there? You might be right, you might be wrong. The point is you had a go, and that's what the mark is for. There should still be some treatment of errors on your graph. I normally see error bars. Error bars are great. Go into Excel, right click, off you go, error bars, thank you very much, job done. And then link any improvements that you might make and any extensions to any weaknesses which you have identified. So your communication, if you've done all these previous things, should be absolutely spot on, because you will have introduced it, you'll have some great chemistry. It will be 6 to 12 pages. Don't worry about 13. That's not a big issue. 14, probably an issue. It gets to 15, we're knocking marks off for communication. And thank you. Make sure there are at least 10 references and use your chemistry. Okay, I have included at the bottom, this is not mine, I've borrowed it from the IB Chemistry Teachers group, for some science simulations and databases. Everyone uses PhET. Everyone uses PhET. Why do they use PhET? Because it works. But be careful. You need to use the simulations where you can control the control variables, not just come out with a known result. So more of this later in this video. Okay, I'll append this to the bottom of the YouTube clip. Hope you found that useful. Best of luck with your studies, and now follow some examples of simulations database. Please don't. Let's have a quick look what's available. Google Science Journal is quite useful. It has a light meter, and it also has a sound meter, which you can use. It's pretty cute on your phone. I've had a look, download it, have a look, see if you can use it. As soon as you start to do anything of any meaning though, however, kinetics of iodine clock, for instance here, it quickly falls apart because you don't have the chemicals at home. Sound, you could maybe follow the sound of a bicarb vinegar thing. I'm not sure what depth you could take that to. Maybe your imagination is better than mine, but Google Science Journal has the beginnings of something fantastic. You can also pay for a colorimeter if you want to pay I think it's 99 cents for this one. Yeah, 99 cents to buy that. That's up to you. I'm keeping everything free that I'm keeping in this video. And of course, the lovely Rich Thornley has done a fabulous video on the activation energy of glow sticks, which you can see here. And you all know Richard Thornley. You don't need to give him any more clicks. Good luck, Mr. Thornley. Is that appropriate for an IA? I'm not so sure. You get an activation energy. There's no variation. It's a cute experiment, though. It should get you some marks if you're struggling for anything else. But you're not, right? So, in this beautiful age, in this beautiful time, we are looking at database IAs. An example on teacher support material is this one, which everyone is familiar with. If you're not, have a look. You can see the website at the top. Have a flick through here. Basically, looking at different substituents, the electronegativities of different substituents, and looking at the effect on the bond angle. Nice data table. It just gives you an idea of the sort of data that the IB are looking for in terms of a good, authentic database-based internal assessment. Very low sources on there. The IB gave that 19 allegedly. I can't see it giving it that myself. Okay, if we were going to have a look at bond length and bond strength, I just Googled it and then I found this little beastie here. We can see that the units here are in angstroms. I had another little look and then I found this beastie here, ChemLibra text. I'm sure you're familiar with this one. The units are in picometers. And I found this little one here. I can't remember what the units are for this. Does it give me the units? Bond energies, we've got kilojoules per mole, and then picometers again. So you've got some unit conversions to do, and again you need to go on for another 10 sources on there for a reasonable data-based IA. There are many research questions you can think of. Look at the syllabus, go through it, and be creative. Okay, moving on. A simulation IA. There's loads of these now. Universities give them out for free. So what is the effect of temperature and concentration? We can do that now. We can have a multifaceted research question. What's the effect of temperature and concentration on iodine clock? This one's lovely. Look at this. You've only got three different temperatures. You've got different volumes of water. The starch is just there as an indicator. It doesn't matter. You've got 2 different volumes of potassium iodide and 2 of the ammonium. Is that thiosulfate? Not got my glasses on. Anyway, you can do this. You can start it, and you've got to get the total volume there. You can play with this, and you can hopefully get some results by playing with it. You can then compare it with another site. This is a nice one too. You can see the link at the top, and you can mix and you can change the temperature. You can change the concentrations, so you can generate some really good data from this. You've got 3 different choices of buffer. How many choices of potassium iodate? 3. And you've probably got that's fixed, it's indicator, and 3 there. So again, you've only got 3 different concentration selections, but over the 1, 2, 3 that you can change, that's 9. So that's pretty good, right? That's pretty good. So explore, have a look. That's what this is about, okay? What are you going to do now? You know how to do it. What are you going to do to be successful in a data-based, home-based learning IA? There's no reason why you shouldn't be getting 24, or at least 20. That's a reasonable target, right? Okay, thank you so much for listening this far. Best of luck in your data-based internal assessment. If you like what you heard, comment, like, subscribe at the bottom. Thank you very much indeed.